In this video, we're going to talk about system of equations and specifically how to solve with the elimination method. So recall that a system of equations is two or more equations. We're going to just look at two here, and the solution can be given a number of ways. So we've got one solution, which is what we're typically going to see, and that's the intersection point between our two lines. If we have the same slope with each equation, then our lines are parallel and there's no solution because they never intersect. Or we might occasionally see two equations that happen to represent the same line, and there's infinite number of solutions there. So for elimination, we want everything in our two equations to be stacked on top of each other. So I like to have it in standard or general form. So I've got my x terms and my y terms on the left side, and then it's equal to my constant c. And kind of similar to the substitution method, we want to eliminate one of our variables. So we're going to do that by combining our two equations. So we're just going to add them together, but we need to make sure that they are set up so that one of the variables eliminates. If we were to add these here, we end up with just 5x. Here we add together and it gets us 2y. So we haven't eliminated either one yet. If that's the case, then we need to multiply at least one of our equations to get it set up something like this here. Okay, so we want the same number as our coefficient in front of x or y, one positive and one negative. So when we add them together, then they will add to 0, cancel each other out, and we're just left with one variable. Now you could subtract, but then you have to make sure that you are subtracting each term, so you're distributing that negative. So I think it's just easier to add everything. Well, 3 and 2, I would have to multiply both of those equations by some number to get these to be the same number. But here, all I have to do is just double 2 to get 4. And we already have one that's positive and one that's negative. So if I multiply this by 2, I end up with negative 4y, which is what we want. And then those will cancel out. So I have to multiply the entire equation by 2. If I just multiply this part, that's giving me a completely different line. So we multiply our bottom equation by 2. So we distribute this 2 here. We end up with 4x minus 4y equals 12. And we're going to add that to this first equation here. So it's just kind of flipped around, but that doesn't really matter. So now everything is stacked. We've got two variables or two terms with the same variable that are going to cancel each other out. And we end up with 7x equals 28. Divide by 7, we get x equals 4. Now we've got the first half of our solution. We go ahead and take that 4 and we can plug it back into either one of these equations and solve for y. I chose the top one because there aren't any negatives in there and it's just easier to work with positive numbers. So we subtract the 12 here, divide by 4, we get y equals 1. So as of right now, my solution is 4, 1, but that only for sure works in this top equation, right? Because that's what I substituted in my x equals 4 to find my y. So I want to just double check, plug 4 and 1 into the bottom equation. That ends up being 8 minus 2, which does equal 6. So that confirms that 4, 1 is my solution. Keep in mind that when you're doing elimination, for the most part, you're going to get an answer like this, and that is when there's just one solution. But we get something slightly different if it's no solution or infinite solutions. So if both x and y terms cancel out when we do elimination, then you're going to end up with two numbers. So it's not going to be x equals 4, maybe it's 7 equals 4, or it's 4 equals 4. So if the two numbers are the same, they're equal to each other, then that tells us that we have the exact same line, and so we have infinite solutions. If those two numbers are not equal to each other, let's say it says 7 equals 4, we know that that's not true. So that tells us that there is no solution because we have two parallel lines.